To evaluate triple integration very easily, we sometimes transfer or change our coordinate system from Cartesian to cylindrical. Okay. Now, what is cylindrical coordinate system? We know about this here. Okay. Here we draw a cylinder because this is a cylindrical coordinate system, and we take the origin at the base of the cylinder and take the x-axis and take the z-axis about the or along the axis of the cylinder. This is z-axis and this is x-axis. Let any point P on the rim of the cylinder, let it be x, y, z, and we project this point on the lower rim of the cylinder, and this is P dash, this is x, y, 0. So we must get P dash, this is equal to z. Here P dash, this is equal to z. Okay. Now we take the y-axis, this is y-axis, and here this line, that is OP, this is the radius of the base, that is the radius of the cylinder, and in this cylindrical coordinate system we take this angle is theta. Okay, this angle is theta, that is the angle this is, we name this point as M, the angle MOP dash, this is equal to theta. And now we draw a perpendicular on the x-axis and perpendicular on the y-axis. Clearly this is P dash and this is Q and this is Q dash, and it is seen that this is x and this is y. Okay, and since this is perpendicular or right angle triangle OP dash Q and the hypotenuse is R, so from this triangle we get the base OQ. This is equal to R cos theta, and we write this is equal to y, and similarly the height P dash Q, this is equal to R sin theta, and this is equal to x, and it is already said that P dash, this is equal to z. So in cylindrical coordinate system, this is denoted by R theta z, and we change from x, y, z to R theta z by the transformation formula. X, this is equal to R cos theta, y, this is equal to R sin theta, and z, this is equal to z. This is obviously no change of z. And now for the cylindrical system, if it is given that this plane is z equal to 0 and this plane is z equal to a, so our range of integration of z is 0 less equal to z less equal to a. Okay, and if we take total cylinder, then it is clear that the value of theta is 0 less equal to theta less equal to 2 pi, and if we take half cylinder, then the value of theta varies from 0 less equal to theta less equal to pi, and if we take the positive octave of the cylinder, then it is taken that 0 less equal to theta less equal to pi by 2. Okay, these are all the variation of the range of the integration in different cases. Okay, so our formula of cylindrical transformation is given by this. Now when we transfer from the Cartesian to the cylinder, we must have to find the Jacobian of this transformation, and it is clear that the Jacobian of this transformation is same as Cartesian to polar transformation, because here no change of z. So if we write the Jacobian, this is equal to del of xyz to del of r theta z, and this is del x by del r, del y by del r, del x by del r, del x by del theta, and del x by del z, and similarly del y by del r, del y by del theta, del y by del z, and del z by del r, del z by del theta, del z by del z, and this must be r. If we put the value of all the partial derivative here, we get the value of the determinant is r. So our transformation is dx, dy, dz to r, dr, d theta, dz. Okay, this is the volume element or elementary volume in spherical coordinate system, in cylindrical coordinate system, and this is in Cartesian coordinate system. Okay, this is the transformation from Cartesian to cylindrical coordinate. Clear? Thank you for watching.